Today's lesson, we're looking at 8.8, acquiring immunity. We are skipping D or E, D, which is the lymphatic system, because we're going to cover that as soon as we're coming back from our excursion. This topic is going to be relevant to us, so we're going to cover this today. All right, so let's start with that. We'll skip the question because it's about the lymphatic system. So today's lesson is going to focus on looking at what is immunity and how you can basically obtain it, right? There are 4 different ways that you can actually obtain immunity. And there's one last one, the 5th one technically, which is not really something you obtain as much as it's achieved, right? We'll talk about that later. The 4 kinds of immunity that you can obtain are related to vaccinations, or basically when you get exposed to the disease and so on. There are different versions of that. We're going to look through all 4 of them, and we're going to talk about the differences between each one of them, and also what it means to have artificial immunity, active immunity, passive immunity, or natural immunity. Okay, we're also going to look at vaccination programs and how sometimes they even use something you guys know as a booster shot in the pursuit of vaccination. So here's a glossary task. So we are talking a lot about immunity. So what is immunity, right? That's the first question. That is basically a resistance or protection against a specified disease, right? Any kind of disease, you basically, if you can't get it for yourself, your body is able to keep yourself safe from that disease, you basically have immunity, right? So all of us, who has gotten chicken pox before? Everyone, right? I assume. Wait, none of you have gotten chicken pox. Chicken pox, the thing that you get as a kid. Whoa. That's so weird. I thought that's the norm. That like I too got my chicken pox at the age of 21, which is why I'm surprised that all of you haven't gotten it yet. Okay. So one thing to note, I'm giving you guys some advice as someone who got it later. It leaves scars, and these scars are much more visible on your face. So yeah, because it's been hidden away. It's technically one is over here, one on the sides. Luckily, most of mine did not come on my face. It's all over my body. But if you're unlucky, it can actually come on your face. So just be careful about that. Yeah, whoa, that really went for a sidetrack for a sec. Essentially, why I asked the question is because a lot of people basically get chickenpox when they're young, and then they never have to worry about it for the rest of their lives because they've acquired immunity towards chickenpox, right? Their body basically can resist any pathogens that are carrying the chickenpox virus trying to get into their body, trying to infect them. Their body can basically keep them safe from it, right? That is what immunity is about. Yeah. Pretty much. You might get measles after that, but that's a whole other story. I have no idea. It literally happened randomly. It happened here in Australia. I was just a random day that I started getting sicker and sicker. At which point I was like, this is much worse than a normal like fever. So I went and get checked up. And then they said, like, you have chickenpox. You have the symptoms. Chickenpox, you have basically the spots and the itchiness, stuff like that. It is definitely chickenpox. Then after that, you have to self-isolate for about a week-ish, a week, 2 weeks. It's actually not that harmful to you, right? You won't, basically, it's not going to hurt you a lot. It's just the problem with it is that itchiness, one thing, at this age, it's much worse for you because you really feel it. Second thing is that it can leave scars. And the problem with getting scars now is that it persists on your skin much longer. If you got it when you're young, it fades over the years. And by the time you're an adult, it's not that obvious. For example, the one that you got a injection for your vaccinations. But getting a scar at this age, it takes a very long time. So basically your adulthood for it to become not as visible, right? So one of the ways you can gain immunity that you guys definitely know of are vaccines. We'll come back to this video in a bit. Let me talk about the different types of immunity first, yeah? So what are the different types of immunity? So we give 4 different classifications to the type of immunity. One is active immunity, another one is passive immunity, natural immunity, and artificial immunity. Each of them describe how or where you gain this immunity from, right? So going into each of them. So when we are actually describing them, we wouldn't describe them separately. We wouldn't just say artificial. We would say artificial passive immunity or artificial active immunity or natural passive or natural active. That is a proper way to define them. But you also need to know why it's considered as artificial or natural or why it's active or passive, right? So when we are thinking about natural immunity, that means that it is gained in a natural way, right? Meaning that your body or it's biologically programmed for it to happen, for you to gain that immunity. That is what it refers to as natural, or in other words, no medical intervention needed, right? You didn't need to get any medical intervention needed. That is natural. Artificial, by definition, means that medical intervention is needed, right? To give an example, you getting a vaccine, that is medically intervened, right? That is actually a doctor or a nurse injecting it to you. That is artificial. Where you get a disease and your body makes the antibodies, that is natural, biologically programmed to happen. Okay? The difference between active and passive is active is when your own body makes its own antibodies, right? Whereas passive is when you receive antibodies from other sources, right? Could be an injection given to you directly that is just purely antibodies, or it could be basically passed to you from your mother when you are still developing as a fetus or during breastfeeding. So we will look at each of them in a bit. So like I said, right, active immunity is when your body is making its own antibodies, and we can obtain that immunity. We can gain that ability to make our own antibodies either in a natural way or an artificial way, right? The artificial way, like we talked about, is your vaccines, right? When you receive a vaccine, you're basically telling your body, here's the disease, make antibody, here's a weaker version of the disease. Now make antibodies for this disease and we will be safe, right? That is what a vaccine is basically doing. Natural way to gain the ability to make your own antibodies is basically getting sick with the disease itself, going through the motions of getting sick, your body activating its adaptive immune response, and then only you getting your own antibodies. So natural is through the disease infection, artificial is through the vaccination. But both are considered active because you are making your own antibodies, right? That's the keyword here, key thing here. Active immunity refers to when you make your own antibodies. And yeah, that can either be gained naturally or artificially. Any questions about here? About this? So looking at our natural it is basically when you get the disease itself, you get a fever, your body's immune system is activated, right? First line of defense has been broken. So the second line of defense is activated. It is fighting off the disease, while your third line of defense is slowly getting activated, right? When your helper T cells get activated and your B cells and T cells also get activated together, that is when your body starts to respond to the disease. If we're looking at our humoral mediated response, that's where you are looking at the antibodies being produced, right? So when the humoral mediated response has been activated under your third line of defense, your body naturally produces its own antibodies to whatever disease is attacking you. Okay, at that point, you have gained the ability to make your own antibodies for that disease. That is why it is naturally happening, right? Naturally, you're getting infected, and naturally, your body producing the antibodies. Whereas here, with your going to the next one,
But before we go to the next one, let me just,
so artificial active immunity, that's when you are talking about your vaccines. It's artificial because medical intervention is needed. Someone, a doctor or a nurse or someone in the medical field is giving you the vaccine for a disease through medical intervention, and then that vaccine is being injected to you, right? So talking about vaccines, you guys have probably heard of vaccines. You guys probably know what vaccines are at a basic level. Essentially, vaccines are a weakened version of the disease, the pathogen, that is meant to trigger an immune response within you, right? They are basically giving you the disease, but making sure it is weakened or inactivated, or it is not the disease even. It's just some antigens that are resembling the disease, the pathogen itself. That is good enough, right? It just needs the pathogen's antigens, and that will trigger the immune response required for your body to become immune, right? That's how vaccines are working. They require the action of memory cells moving forward after you've gotten your first vaccination. Your body makes the antibodies. Makes the antibodies required to fight off that pathogen, and then anytime after that, your memory cells will basically get triggered if that disease tries to come back, if that pathogen tries to infect you again. Let's just watch the video right now.
Rejects. In 1796, the scientist Edward Jenner injected material from a cowpox virus into an 8-year-old boy, with a hunch that this would provide the protection needed to save people from deadly outbreaks of the related smallpox virus. It was a success. The 8-year-old was inoculated against the disease, and this became the first ever vaccine. But why did it work? To understand how vaccines function, we need to know how the immune system defends us against contagious diseases in the first place. When foreign microbes invade us, the immune system triggers a series of responses in an attempt to identify and remove them from our bodies. The signs that this immune response is working are the coughing, sneezing, inflammation, and fever we experience, which work to trap, deter, and rid the body of threatening things like bacteria. These innate immune responses also trigger our second line of defense, called adaptive immunity. Special cells called B cells and T cells are recruited to fight microbes and also record information about them, creating a memory of what the invaders look like and how best to fight them. This know-how becomes handy if the same pathogen invades the body again. But despite this smart response, there's still a risk involved. The body takes time to learn how to respond to pathogens and to build up these defenses. And even then, if a body is too weak or young to fight back when it's invaded, it might face very serious risk if the pathogen is particularly severe. But what if we could prepare the body's immune response, readying it before someone even got ill? This is where vaccines come in. Using the same principles that the body uses to defend itself, scientists use vaccines to trigger the body's adaptive immune system without exposing humans to the full-strength disease. This has resulted in many vaccines, which each work uniquely, separated into many different types. First, we have live attenuated vaccines. These are made of the pathogen itself, but a much weaker and tamer version. Next, we have inactive vaccines, in which the pathogens have been killed. The weakening and inactivation in both types of vaccine ensures that pathogens don't develop into the full-blown disease. But just like a disease, they trigger an immune response, teaching the body to recognize an attack by making a profile of pathogens in preparation. The downside is that live attenuated vaccines can be difficult to make, and because they're live and quite powerful, people with weaker immune systems can't have them. While inactive vaccines, don't create long-lasting immunity. Another type, the subunit vaccine, is only made from one part of the pathogen, called an antigen, the ingredient that actually triggers the immune response. By even further isolating specific components of antigens, like proteins or polysaccharides, these vaccines can prompt specific responses. Scientists are now building a whole new range of vaccines called DNA vaccines. For this variety, they isolate the very genes that make the specific antigens the body needs to trigger its immune response to specific pathogens. When injected into the human body, those genes instruct cells in the body to make the antigens. This causes a stronger immune response and prepares the body for any future threats. And because the vaccine only includes specific genetic material, it doesn't contain any other ingredients from the rest of the pathogen that could develop into the disease and harm the patient. If these vaccines become a success, we might be able to build more effective treatments for invasive pathogens in years to come. Just like Edward Jenner's amazing discovery spurred on modern medicine all those decades ago, continuing the development of vaccines might even allow us to treat diseases like HIV, malaria, or Ebola one day.
Right. So looking at that, you can see that vaccinations play a huge role in acquiring immunity in the modern society that we live in, right? And it works through the action of memory cells, right? So essentially, when you get a vaccine, your body triggers its adaptive immune system, right? Basically, these two pathways are activated, the humoral immune response and the cell-mediated immune response, right? Where your B cells start making antibodies and also B memory cells, and your T cells make cytotoxic T cells and also T memory cells. So at that point, the vaccine is also inactivated, so it's not going to pose a threat to your body. But what's important to note is the memory cells that have been produced, right? These will persist in your body along with the antibodies and the cytotoxic T cells for a prolonged period of time. And what that means is that if you get invaded by the same pathogens again at a separate time, these memory cells will get triggered very, very immediately and also at a stronger level, meaning that they will start making massive amounts of antibodies and cytotoxic T cells to combat that pathogen's advances. That means that as a result, your body's immune response has been sped up and also improved because of these vaccinations. And that's why you are basically immune to that pathogen moving forward. Your body has been trained to be able to deal with it, so it knows what to do as soon as it detects the pathogen, right? So this only works because the vaccines that you get basically have the antigens of the pathogen, right? The markers that can be used to identify any type of any type of pathogen. Since it has these antigens, it will then trigger the adaptive immune response. And since they are also inactivated, or basically these different versions of them, they actually come with without the risk of actually causing the disease, right? Very, very rarely has it ever been the case where a vaccine has even caused the disease that it's supposed to protect against. I've never actually heard a case of that happening. So when we look at the different vaccines that are being used in the current age, we have a few different types, right? There's the mRNA vaccine. That's actually a very recent discovery, recent advancement in science that brought about mRNA vaccines. In fact, if any of you heard about it, during COVID, the reason why we were able to make a vaccine as quickly as we did is because we had done so much research on mRNA vaccines prior, and it was the perfect chance for them to use whatever they've learned to make the mRNA vaccine for COVID, right? What is the mRNA vaccine? It's basically RNAs, which are the instructions in your body. They will be injected into your body, and what happens is that those RNAs will ask will basically make your cells produce those antigens of the disease, right? So even though your body is actually producing those antigens, it is still an antigen of the disease. So that's why it will still trigger the immune response. So I know it's very confusing to hear about mRNA vaccine because mRNA vaccine is actually the mRNA actually programs your own cells to make the antigen. So why isn't it being detected as self if it's made by itself? It's basically the reason why that is that the instructions in the mRNA are specifically only to make the antigen of the pathogen and nothing else to be added onto the antigens itself, right? So there's no other trace of self on those antigens. They're only the traces of the pathogen. So that's why it will trigger an immune response. Then there is your live attenuated vaccine, your inactivated vaccine, and toxoid vaccine. These are all different versions of basically just antigens being injected or into your body, right? How are the antigens injected into your body? Whether the pathogen has been weakened before injected, whether it was basically not eradicated, but basically killed before it was put into your body, or you're putting in the toxins that are associated with the pathogen as well. That can also trigger an immune response. As long as it's antigens from the pathogen, it will end up triggering an immune response, right? That's why we can use any one of these vaccines, but depending on the disease and depending on the needs of society, they can focus on using one or the other, right? So all versions of the vaccine will trigger that response because the antigens that they have are not self, so they will be recognized by your body's immune system as being a foreign pathogen. So it will trigger an immune response. And when that immune response has died down, the memory cells that have emerged from that immune response is what will keep you immune moving forward so that you don't get sick or you don't get infected with any pathogens later on. Sorry, you don't get infected with those specific pathogens later on when the disease actually tries to infect you. All right. So if you want the details of which vaccines were being used for which disease, you can have it here. And they're basically just describing each vaccine, where attenuated is where the pathogen has been grown in a lab but altered significantly to reduce their virulence. Basically, how easily can they spread? And that means that it's most unlikely to cause the disease or have any side effect. Inactivated is when they've been grown in a lab but have been killed or destroyed so that they can't cause the disease. Toxoid is basically the toxins being produced by the pathogen itself, used as an antigen to cause an immune response. And then virus-like particles, that's also another one where a protein capsid with antigens on the surface is then injected into your body, and those antigens then trigger the immune response. Any questions so far? All right. So the most important thing, like I said a few times already now, is that regardless of which type of vaccine you're working with, it's all about the antigen being there, the pathogen's antigen being there. That is what triggers the immune response. However, those antigens are irrelevant. All right. So how many vaccinations do you actually need, right? So you guys pretty much, yeah, I'm pretty sure all of you have gotten your COVID vaccinations, and everyone here probably got 3 vaccinations. Why is it you got 3? And for certain pathogens, you only need 1. Most of them, you probably need 2. Why is it? What determines that number? It's basically the curve of antibody concentration can explain that, right? Let me show you guys what I mean. So when we're looking at our antibody concentration, this is basically showing you the humoral immune response when your body has been exposed to the pathogen. So during your first vaccination, that's when you get the pathogen inside you. That's when you get the vaccine inside you. The antigens then trigger an immune response. and that means that your body starts to produce antibodies, right? But since it's a vaccination, it doesn't take long before all the pathogens have been eradicated or basically deactivated. So it's no longer an issue for your body. So at that point, your body basically slows down or deactivates the immune response. That's why you can suddenly see the antibody count dropping drastically, but it's not gone to zero, right? If you zoom in very closely, there is still some amount being produced here. That is where your body will be maintaining a small amount of antibodies and also memory B cells from the initial exposure in case the same pathogen tries to infect you another time. And then if that happens, your body suddenly kicks into overdrive using those B memory cells to produce an excessive amount of antibody so that it doesn't have to worry about another infection. That's where your second vaccination comes in. So the second vaccination is basically stimulating a second exposure to the disease, to the pathogen, to trigger a much stronger and long-lasting immune response from your body. Because the first time you got the vaccination, since it's so weak, the pathogen, your body does not recognize it as being a very significant threat. So it won't produce a lot of antibodies. It won't trigger a massive immune response. In fact, just by triggering this much, it can deal with all the problems. So after that point, your body recognizes the pathogen, but isn't taking it seriously. That's why we need to basically give ourselves a second vaccination, a second dose of the pathogen, so that your body thinks this pathogen is sticking around. We need to deal with it very seriously. So it goes into overdrive and produces excessive amounts of antibodies so that it doesn't become an issue ever again. After this period, you can see that the graph drops again, right? This is the reason why we will sometimes require a third booster shot. This immunity will wear off eventually. Your body is not used to producing so much antibodies without a proper reason. So once it knows that the pathogen has been dealt with, it won't just continuously produce the same amount forever. It will slowly subside and slow down over time since your body doesn't recognize it as being a threat anymore. Right? Like you see here. So first vaccination, there's going to be a delay in the adaptive immune response. That's the delay. Basically, it takes a few days for your third line of defense to get activated, right? So that's why there's a delay. And that at that point, when it does get triggered, both the humoral and also cell-mediated immune response are triggered. And at that point, a moderate number of antibodies and moderate amount of antibodies and memory cells are formed, which will then diminish over time. So only due to the exposure during the second vaccination, your body basically uses the memory cells from the first vaccination and triggers a much faster and stronger immune response to combat the pathogen. It doesn't know how serious it is, even though it's the same amount of pathogen, probably a very small amount, your body will still take it very seriously because it's a second exposure, right? Your body does not want any danger from the second exposure, so it takes the B memory cells and it produces an excessive amount of antibodies to make sure that there is no risk from the pathogen anymore. Right? So, like any other cell, those memory cells will eventually die as well. So that will actually drop your immunity to a certain disease, to a certain pathogen over time. But this will take a much more longer period compared to the first and second vaccination, right? If you want an example of that, think about when you got your first two vaccinations for COVID, and then think about when you got your booster shot, right? The first two vaccinations would have happened at most a month between each other, whereas the booster shot, you probably got it a few months after your second vaccination, if not later. Not sure about all of you. Maybe some of you might have gotten sooner, but it's usually supposed to be after a much more longer period because they wait for your immunity to drop a certain bit and then only give you the booster shot, and that's basically supposed to bring it back up, right? In the same way that it did for your second immune response, sorry, second vaccination, it will just bring up the number of antibodies produced back up again and keep you immune for that period, right? Certain pathogens, you don't get a permanent vaccine, permanent immunity. Certain ones you need to take booster shots there at times as well. But there are also pathogens out there that you have a lifetime immunity towards, right? For example, like I said, with chickenpox, your body keeps up a decent amount of antibodies and memory cells such that you never have to worry about getting the pathogen and never have to worry about getting the infection again. It will just keep you safe from it, even if you're exposed all around you, right? But with stuff like COVID, since it is mutating so fast, since there's so many changes to the virus, there is no way for you to keep up with booster shots. So that's why you're not continuously taking more and more COVID booster shots. It's not gonna be feasible for you to do that. So we dealt with it by giving everyone 3 shots, and then we just move forward from there. So now that we've talked about active immunity, which is where your own body makes the antibodies, let's talk about passive immunity, where you basically receive the antibodies you need to protect yourself for. So antibodies will be supplied to you rather than your body making its own antibodies. And how you get those antibodies, whether it's natural or artificial, is going to be different, right? Natural is when those antibodies are being supplied to you in a biological way. Basically, think about when a fetus is in the womb, there is a umbilical cord attached to the placenta. This is basically a way for blood and other nutrients to get exchanged between the mother and the fetus. And another thing that is also exchanged is antibodies, right? The mother will produce antibodies that will also go into the fetus as well during the pregnancy, because the fetus is still actively developing its immune system, so it can't just fight off any pathogen or infection on its own. So it needs antibodies supplied to it from the mother, either through the placenta, or it can also happen right after childbirth in the early days of infant through breastfeeding, right? Breastfeeding or breast milk actually contains antibodies as well. And that is also important to the child because a developing infant is still developing their adaptive immune system, and they can't just combat any pathogen by themselves. That is for natural, because that is naturally happening, right? Breastfeeding, antibodies being exchanged to the placenta, that is a natural system that has been in place to exchange antibodies between one being to the other. An artificial way this happens is through the injection of antibodies, specifically stuff like antivenoms, right? That's the best example you're going to get. So where antivenoms are basically given to patients who've gotten a snake bite, that is basically antibodies that are dealing with the toxins coming from the spider or snake or whichever one, right? Whenever those antibodies are given to you as a shot via medical intervention, those antibodies are also sometimes manufactured or extracted, but they are artificially obtained and artificially given to you. So that's why they are considered as artificial passive immunity, because you get antibodies in an artificial way. That's what artificial passive immunity is talking about. So, like I said about natural passive immunity, either through the placenta or through breastfeeding, both are basically exchanging antibodies with the fetus or new infant, and both are required because of the fact that that infant or newborn baby, that infant or fetus is still developing their immune system, right? They can't combat any pathogens themselves. They need the antibodies supplied to them. That's why this is needed. And since they are supplied in a natural way, either through the placenta or through breastfeeding. That's why it is called as natural passive immunity, right? Next one, which is artificial passive immunity. That's when, yeah, like I said, it is artificially given to you, right? Antibodies are produced and supplied in an artificial manner via medical intervention. A specific example is when antivenoms are supplied to those with snake bites. Snake venom is a type of pathogen that is trying to act on you, right? Antibodies are basically to combat that venom, you need an antivenom. And antivenom is basically antibodies that are designed to neutralize the toxins of the venom itself. And one thing to note about this type of immunity is that it is very short-lived and not reproducible, right? Meaning that since you're only getting the antibodies, you're not getting the memory cells, your body does not recognize the pathogen. It only has the defense against the pathogen. And then once that defense all dies off, the defense is gone already. You don't have immunity anymore. Because if your body does not recognize the pathogen and it does not have the memory cells to make more antibodies later on, then it will just use the antibodies that are present until they're not present anymore and it's over. All right, any questions about the 4 types of immunity so far? All right, so artificial is obtained through medical intervention. Natural is obtained without medical intervention. Just remember the medical intervention. Artificial is with medical intervention. Natural is without medical intervention, or in a natural way, if you want to remember that. Active is when your body produces its own antibodies. Passive is when you just receive antibodies. And then you just combine them to make a new thing by itself. Natural active, meaning that you naturally make your own antibodies, right? Artificial active means that you artificially make your own antibodies, vaccines. It's artificially being injected to you through medical intervention. So that's why it's artificial. And talking about passive immunity, natural passive immunity, that's a natural way antibodies are supplied to you. And next one is artificial passive. Basically, that's the artificial way antibodies are being given to you, right? Just remember that, and you should be able to describe them when you need to. How comes herd immunity? You guys have definitely heard this one during the COVID period, where when vaccinations came out, everyone was trying to encourage others to go get the vaccination because we want to get a herd immunity so that people who are at risk can be protected from the disease itself. Basically, herd immunity is when rather than we're no longer looking at one person's immunity, we're looking at a community's immunity, and that is only possible because of individual people getting vaccinated, or individual people being immune to the disease by themselves, right? So when there's a sufficiently large enough portion of the population that has gained the immunity, what happens is that even those without the vaccination or even those without the immunity are protected from the pathogen, because the pathogen causing that disease cannot easily reproduce or spread around because too many people are immune, such there's not enough pathogen to actually spread. Think of it like, how to describe this in an easier way to understand. Yeah, so let's paint a picture here, right? This is a community and they just got ravaged by a pathogen, and they just got vaccinated for a pathogen, and this person could not get vaccinated because they could be allergic to the vaccine, or they could have some personal reason why they don't want to take a vaccine, or they could just be stubborn and don't want to listen to medical advice. Could be any one of those 3. Either way, the point is, since so many people in the community have already gotten immunity for that pathogen cannot exist in this community anymore, right? The chances of this one person somehow magically catching that pathogen are very low. it would have to spread from one person to another person and then eventually get to that person. But since everyone else is already immune, there's no chance for it to spread anymore. And the chances of this person becoming infected with that pathogen are ridiculously low at that point. That's why it's referred to as herd immunity. This person is only safe as long as he stays in this herd. As soon as he goes into a different community, he might lose that protection at that point, right? That's why when COVID vaccines came out, they said 80% of the population needs to get vaccinated for us to develop some kind of herd immunity, or 90%. Depending on the disease, the exact numbers can actually be different. Sometimes it can be a very, very contagious disease. That means you need a 95% vaccination rate to have herd immunity. If it's not as easily spread, you probably can get away with 60 or 70 or 80%. That all depends on how virulent the disease or pathogen is, right? So the major effect of this is that people without the vaccination will basically be protected as well, right? It's a protection without actually having to do anything because everyone else did something for you. Yeah, so at first, no one else is immunized. The contagious disease spreads through the population, and then suddenly so many people have been infected, right? If some of the population gets immunized, it's still going to be a problem because it can spread through those who have not gotten immunized. However, if most of the population then gets immunized, the chances of the disease being able to spread through this population are so low that the chances of these individuals specifically getting the disease is also somewhat low, right? Does anyone need a further explanation about this? No? Good. So yeah, that's basically it, right? So thinking about all these, the 4 different versions of those immunities: natural, active, natural, passive, artificial, active, artificial, passive. Natural is the one that doesn't require medical intervention. Artificial is the one that does require medical intervention. Passive immunity is the one where you receive antibodies from external. Active is when you receive it, when you make it on your own through your immune system, right? And then there are the examples across, right? Antivenom is artificial passive. Vaccines are artificial active. Antibodies being given to you by your mother through breast milk or through the placenta, that is natural passive. And natural active is when you get infected with the disease and you make your own antibodies.